Let's begin with a simple observation. It's easier to push a door open when you push farther from the hinge. That's because you're applying a larger moment, also called torque. The moment of a force is the measure of its tendency to rotate a body about a point or axis. It depends on two things: the magnitude of the force and the perpendicular distance from the axis of rotation. The formula is straightforward: moment equals force multiplied by perpendicular distance. Its unit is Newton meter. So, the farther from the pivot you apply the force, the greater the turning effect. Moments can act in two directions, clockwise or anticlockwise, and understanding this is key. A clockwise moment rotates the body in the direction of a clock's hands and is considered negative by convention. An anticlockwise moment rotates the body in the opposite direction and is taken as positive. For instance, when you tighten a screw with a screwdriver, you apply a clockwise moment. When you loosen it, that's an anticlockwise moment. These directions are vital for problems involving rotational balance. Now, let's explore the factors that influence the size of the moment. Firstly, increasing the force directly increases the moment. Secondly, the farther the point of application is from the axis, the greater the moment. This is why levers are effective. Interestingly, if the force passes through the axis, the perpendicular distance becomes zero and the moment is also zero. Also, the angle at which force is applied matters. A force applied perpendicularly is most effective, while an oblique force reduces the turning effect. We see moments at play everywhere around us. A longer spanner makes it easier to turn a bolt. More distance equals greater moment. Steering wheels rely on torque to control the vehicle's direction. Doors, levers, crowbars, all these tools use the principle of moment to reduce the effort needed. Even your hand muscles apply torque when you lift or rotate objects. The turning effect is central to how we interact with machines and our environment. Torque isn't just a scalar quantity, it's a vector. That means it has both magnitude and direction. And to determine its direction, we use the right-hand rule. Point your fingers in the direction of rotation and your thumb points in the direction of the moment vector. This is particularly useful in three-dimensional systems like robotics or advanced machinery where direction matters for control and balance. Let's work through a numerical example. Suppose you use a spanner of length 0.3 meter and apply a perpendicular force of 20 newtons. To find the moment, we multiply the force by the distance. 20 multiplied by 0.3 gives 6. So, the moment of force is 6 Newton meter. If this force causes clockwise rotation, we assign it a negative sign. Hence, the final answer is minus 6 Newton meter. Always remember to check the direction and units in your solution. To wrap up, the moment or torque is the rotational effect produced by a force acting at a distance from an axis. Its magnitude depends on both the force and how far away it's applied. Moments can be clockwise or anticlockwise and are used everywhere, from opening doors to operating machinery. Recognizing torque as a vector helps in solving more complex physics problems, especially when dealing with multiple forces. This foundational idea prepares us for understanding how forces balance, leading us next into couples and equilibrium of bodies.